Okay, now we talk about data collection. Then what is the data? So measurements or observation are the data, but we will discuss about them later. We have the two types of data, naturally occurring data and another type of data we have, let me see. Naturally occurring data, we have measurements and observations, and artificial data, which are based on simulation. These type of data are based on at this level, we start come to observation, measurement, or simulation. They are called primary data, and they are collected is to answer the research questions. And for the type of data, should be selected in such a way that they will help you to come to answer the research question. And we have other type of data. For example, documented studies, source criticism. These are secondary type of data, and which are used for other purposes. Sample is a representative of a population. So we can do sampling in different ways. Sampling. So we have a population, for example, we have a company producing lamps, and the product is generally the product of this company is a population. And if we want to check the quality or conclude something from for this company from this product, we take a sample. This sample helps us to draw conclusion about the population. So how do we do this sampling? So we say sampling has two: probability sampling. So what does mean? It's based on the probability theory. Let me explain it. A random sampling. So if you go and do discuss about or conclude something about the population, you will go and take some products, some samples, some values, some of the products by random means. So this is called random sampling. Systematic sampling is a way that you have a rule for measuring, for taking a sample. For example, company is producing the lamps, or the manufacturer produce the lamps, and every day or every month you will take the sample. Then you have a systematic rule for sampling. So you can have a stratified sample. It's based on the characteristic, for example, size of lamps. Okay, big lamps, small lamps. Or if you are in a company, you are working with qualitative data, men or women. So you are stratified this. Or clustering. Clustering is one step forward in the statistics. For example, if you will divide the group into different clusters, the population different cluster, and then go to each cluster and define a stratification for that each cluster. So it's based on the group. You will group the data before them. So non-probability sampling is a target-based sampling. You have a specified goal for sampling. Specified goal for sampling. And for example, it is mainly with qualitative data, for example. And for example, I want to study an organization about the feeling, human feeling about the work environment. So I will go and select people of that company. So that organization or company. Then I have a target base. I cannot you cannot go and talk to everybody. So, for example, I can say, okay, I want to discuss how women feel in such a working environment. Then I have a target. Then I will go and talk to women. I will get the information. Or convenience. Another way is a convenience. I will select as I feel this is simple for me. I decide whatever. It's the simplest one. A snowball, for example, I want to study how Iranians, for example, feels they feel about the working environment. So I will go and talk to those I know, and thereafter, based on this that I know, they will say, okay, you can talk to another guy. Then I will go and talk to, and that guy connect me to other guys. So it is like a snowball. So I start with a small sample and gradually increase it. It's like that I make a snowball. So we can have this type of the probability sampling and non-probability sampling. Probability sampling is mainly for quantitative data, non-probability sampling, qualitative. But I cannot give you a general rule for that. It is always like that. It depends. It depends. In such the subject, it's not like mathematics 2 + 2 is 4. It depends. Sometimes 5, sometimes 1, sometimes 3. So what is important is that you need to think about sample size when you want to do sampling. Measurements. A technique when used for collecting data on a phenomenon in reality. So when, for example, when you talk about temperature, you know what something is hot. Then you will go and measure. Then you measure the temperature, then you have a measurement. Then you have assigned the symbol to that one. For example, T is called for temperature, and you will give a number to it. Then it is measurement. A symbol and a number. That's a measurement. So for each measurement, we have a scale. This type of a scale, we have nominal. Nominal scale is a scale that we have the lowest number of information, not possible to rank. For example, we show football player with numbers just to recognize them. The number doesn't mean anything. For example, if the number 1 should be the goaler, the person who is protecting the goal. No, it's no rule for that. It's just for classification and just to recognize. So, for example, when you want to solve a problem, you consider, okay, I call this parameter A and call the other one B, the other one C, just to recognize them. The order is not important. I can call the first one B and second one A. Doesn't matter. It's like a name that we have. We have different names so that we can be recognized. Otherwise, it's very hard to recognize people from each other. It's specific called nominal value. Ordinal value, as the name shows, this order is there. It's possible to rank people. For example, when some people they are in a running match, the 3 winners, the first one will be 1, the second one will pass the end line, the second and the third one. What does it mean? It means that the first one was fastest, the second was the second fastest, and the third one the third fastest. So numbers here, they have meaning. This means rank. You are ranking the data. This type of data are ordinal, nothing else. It doesn't mean that if we don't know, so the first person went past the finish line, we don't know that how long after the second person comes to the second line. Maybe 1 second, maybe 10 seconds. We don't know. We just know that this is the first one and this one is, and the other one is the second. Or we don't know the distance, the time difference between the second person and the third person. The third, it doesn't matter. It's not important. Then we have this type of data that we use to rank the data or rank the information. It's called ordinal data. We have interval data. They are possible to rank, and also they have equal distance. For example, look at temperature. Temperature is one of the interval type data. What does it mean? It means that we have, for example, temperature from, let's see, -30 up to +30. And of course, when the temperature increases, the number increases, the temperature increases. Then we have rank. Higher number, larger number, higher temperature. And equal distance. It means that between 40 and 45, we have 5 degree of Celsius temperature difference. It is equivalent between 10 up to 15 degree. This is 5 degree of temperature. This 5 degree is the same all the way in this case. And ratio data is the numbers that we use, for example, possible to rank and equal size and natural zero. What does it mean? Let me explain it by temperature. If your temperature is as interval scale, you get 0, it means that it is very cold. It doesn't mean that temperature does not exist. But in ratio data, then the ratio scale, when we say, for example, weight, when weight gets 0, it means that things does not exist. If the length is 0, it means that the length does not exist. 0 here is not, it doesn't mean that it is a non-existent here existence. If something is 0, then it does not exist. So, but in interval data, 0 has a meaning. So 0 means the 0 temperature. Or with some type of data, 0 means nothing, empty. So this is the way to recognize the difference between interval and ratio scales. Keep following in mind during measurement. What is to be measured? What is going to be measured? So, for example, if you want to measure heat, do you measure the heat directly, or you measure something else and determine and compute the temperature or heat from it? So, what is going to be measured and how? Is it direct or indirect? How is it to be measured? It means which instrument do you measure for that? Is that instrument capable to measure it directly, or is this instrument measure something else and calculate everything inside and give it to you as a number, the final observation? And how good is the measurement? That's the things that's very, very important. And we have two concepts here: precision and accuracy. Precision, it means that how much this is related to repeated, how much we can repeat the measurement, and how these data are close to each other. And accuracy means that how close the measurements are to what they should be. Let me give you an example here, show you an example. So I have a board. Yep, one board here, one board here. And I have asked a person with a gun to shoot the board. Some shoots like this. Some shoots like this. And if I have another board here, and some shoots like this. As we see here, the measurements are close to each other. This means that they are precise, but not accurate, because the target is here. Probably the shooter has pointed to this point, to the center of the target, but he has shoot the shoots or the bullets collide the target here. It means that the instrument is precise but not accurate. There is something systematic inside it. But here, they are all around the center of the target, and probably they are accurate because they are around, but not precise. And at the last case, it's the center of the target, and all are close. It is precise and accurate. So they are not the same kinds of precision and accuracy. Precision means that if I repeat the measurements many times, the points will be closer and closer and closer and denser and denser. But accuracy, it means that the distance from reality, what this measurement in reality should be, or how far are they from the real value. So if you have a real value of a quantity, let's say L, and I do a measurement for that, the difference between what I have measured and what it should be is called error. So that's simple to understand, error. But how this error, what is the properties of this error? This error can be systematic. It's quite natural that when you measure something during summer, for example, with the tape, because of the heat and the temperature, this tape will be expanded. And you measure all distances shorter than what they should be. And during winters are the opposite. Or for example, you know that there is a problem with your instrument, and your instrument or a tape you measure for it, and they have is missing 33 centimeters in the beginning, and the tail of the tape. So whatever you measure will be 3 centimeters longer. Even if you repeat it, the precision will increase, but this 3 centimeters is already there. And all these measurements contains these 3 centimeters miss. This is called this is a systematic. The problem with the system or problem with the nature. They come from nature or from the instrument. So this type of error are systematic. So you can model it simply. So if 3 centimeters is missing, okay, I can add a tape of 3 centimeters to that, so I can correct it. Like this means something, a calibration. So calibration so if you expect that its instrument should give you some specific value, okay, you know that value, you put the instrument there, and you will expect that this instrument gives you that value. There's some sort of checking, and if it is not, you will adjust the instrument to get that value. Then it's calibration. You will calibrate it. The other way to do it is to correct it mathematically. So you know that you are missing 3 centimeters of the tape, and you measure all lengths 3 centimeters longer, and you will add 3 centimeters to all of them. You make a mathematical formula for correcting this. That's the way that you can work with system. And gross errors are the big mistakes. Big mistakes they are normally detected by checking the data. But random data, they have no specific rule. If I measure it, now I get some value. If I repeat the measurement, I get another value. It is not like that. It is in one direction. It happens sometimes positive, sometimes negative. This is why we use plus and minus. For example, 100 plus and minus 5. This means that this is of random nature. 105 or 95. This is between them. And this type of errors can only be reduced by repetition. When you repeat the measurements, then when you repeat the measurement, this error reduces because it comes sometimes negative, sometimes positive. When you take the average, it will be 0. The end. Or close to 0 at least. This type of errors, then you can, after removing the systematic ingress error effects, what remains is random. Random errors are always on the measurement. Always. And the best way to handle it is to repeat the measurement as much as possible. When you do so, you will reduce this error. You can never make it 0. You will reduce this error by a statistical method. Advantages and drawback of measurement. So, replacing subjective estimated by measurement. So you expect that something is, when you look at the distance between 2 points, you measure, okay, it should be 100. It is my guess. It's a subjective estimate. Then I go and measure it. Then I will make it more realistic. So I replace the subjective estimate by measurement. Are repeated by different people at different points in time. Okay. Managing and processing data in a systematic way. These are the advantages of the measurements. Drawback, many sources of errors are inside. One may be misled by a numerical value. Okay. For example, I can make you tell you a story. There was a company monitoring the formation of a big building. It was a tower. Probably you know it was tower, Villa Tower, in Tehran, and they were responsible for measuring the formation of this building in time. And of course, they measured coordinates around the area, some points, and they determined the coordinate every 6 months, I think. And they made a time series of this data. And this time series contained a trend and some small variations. So therefore, talking and these small variations are very in random level. But that company tried to interpret that. So that was the reason that they could not get the job in the next session for deformation monitoring, because they discussed about noises. They couldn't recognize the noises from the systematic trend showing that the building is moving in that direction. So this may be misled by a numerical value. And measurements are always have certain level of inaccuracies. Observation is not measurement actually. Observation means observe, to watch. And when you want to do an observation, you should keep in mind the relationship between the observer and observant. So, is it direct or indirect? Structured or unstructured? Execution, how do you execute, where, when, time, and impact of the observer. So, Let me explain a little bit more about that. For example, in our organization, we want to see how a process in this organization or how the job is working there. So a researcher goes there and observe. It could be directly observed or no. He sits in his office and gets just some information from some that. That's called direct and indirect. Structure, it means that if they have some special structure to do this observation or no, they will go inside go to the organization to see what they see, to see what they can notice. But the structure, it means that they have already decided which factors they are going to note and they are going to observe the process or something. Execution, where it is executed, inside the building, inside a lab, at what time? Is it the time that people are in the organization or people not inside the organization after the working time? Is it accessible or not? Is it night or during day? These are all important. Impact of observer, how much the observer can impact this observation. I mean, this is bias. It can observer influence. We can observer can also put his or her his own interpretations in the observation. So, degree of observation. Let us look at this table from the above and below. So outsider, it means that the observer is not involved in the activity. They go to this organization and just observe. And even they are not allowed to interact. They just observe. No inside act. An insider is a person who is inside the organization. Inside the organization. So part of the study situation. And between these two, we have three other levels. So passive, the observer is inside the organization, but it does not interact. He or she doesn't. Moderate, it is balanced. But between inside and outside. And active is a person who can interact with people and discuss with them. For example, we want to see satisfaction of employees in an organization. First of all, it is important that to decide: is there do we need to inform the employees that a researcher is going to be there for checking this or not? So in this case, if they know it, probably they behave differently. And do you feel comfortable when they feel that somebody is observing them and making known? In this case, maybe it's better not to inform the employees. And this guy or the observers can do everything in such a way that it is not seen or is not sensed somewhere. Or maybe the organization can introduce the researcher as a new employee and put him inside the organization. And he or she just does his own work, but nobody knows what he is. And nobody should know that he's doing, because it will influence the employee. This is just an example. Or sometimes is moderate. They can, for example, in moderate, this observer can also interact with the study. They can talk to people. They can go, but not that much. They try to be inside, in the between insider and outsider. And actually, they are working with others, working with people, and discussing. Like he can discuss with people. And inside it, one person from inside this study is selected. Direct and indirect observation. Direct observation means that in the same time and space, the observation occurs. The one person goes to some places at a specific and observe. Time and observation and the space coincides. Or some sort of indirect is some form of measuring instruments. For example, he or she will go inside the organization and use some instruments, but could be some another person, could be some, for example, some cameras. You can do the observation in that way. It doesn't need maybe the recorded video. That's fine. That's for that. Not observation and time at the same time together. Structured or unstructured. As I said, you have a protocol to follow, and you go and to a company and you want to observe a process, and you have certain criteria, and you will check if this process is following that criteria, how far are they from that, and you will take notes. For the second part, that is unstructured. You just go there to see what you can see, what is important to see. You will decide on that time, not before. This is unstructured observation. How do we do it? The place could be natural place. You go to the building, go outside to the field, or it can be artificial environment like labs. A suitable time. Of course, if you want to study employees situation in a company or organization, of course, you will not go there after 4 o'clock, or should be there during daytime. So this suitable time. Formal permission for observation. So this is important that the head of this organization should know about that and give you the permission so that you can enter the building or enter the cell. And the people to be observed should agree. This is that the execution you should consider when you execute an observation. Advantage. Observer can be an instrument. Has no extra material. This is just a person go and do observation. So nothing more than that. That's good. Gain a good insight concerning phenomena. Yes, they can see, they can go inside and be part of that organization to understand it. It's a real-time study of a complex event and provide rich data close to reality. What are the problems? Access to natural environment may be difficult, of course. Participant observation is difficult as it requires commitment to resources and time. Reliability depends on the skills of observer. Generalization of result may be difficult. Maybe more than one observer is needed for doing such a study. And also the observer matter of taste can influence the result.